Of course, there are different events that allow it to lose a little bit, but it can lose all of it because it's recycled back into other stars. To determine the future fate of a star, mass is a variable, but it is not the only variable. They evolve by huge amounts, and they do eventually stop shining. We know this because we see how they evolve stars, and sometimes we can't see them, and the reason why we can't see them is because they no longer shine. They don't have any huge plasmatic atmospheres like the sun does now. Youthful stars have very intense light. We're talking X-rays and gamma rays. As well, the mass. Very massive stars are very young. They have yet to lose their mass, and the old stars are a lot less massive. They have lost all their mass as they evolved. Really young hot stars can't form chemicals, but as the star evolves, the chemicals can form because the star cools down enough for those chemicals to form. The Sun being the youngest, and all the way down the line, Jupiter, Saturn, Uranus, Neptune. We know it's iron because of iron-nickel meteorites. Those are the cores of smashed up remains of stars, and those enter in the atmospheres of other stars and reform the core. They're recycled. Mercury is peculiar because it's had its outer layers of its mantle completely torn apart and ripped apart and shredded. And to dig into Mercury's inner regions that far would have to have placed Mercury as a very, 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 very old object. As well, it should be evident because Mercury's surface is pitted with numerous impact craters all over its surface, all over the place. It's a completely dead world, and it's been dead for a very, very, very long time.